now that we know what sine, cosine, tangent are, now we're going to start using them to find the areas or find unknown sides of triangles. Areas is something we'll get to later. So we can use this to solve. Now, just a quick refresher. Our favorite phrase here is sorry, the S didn't write, toa, which means that the sine of the angle is the opposite over the hypotenuse. The cosine of the angle is the adjacent over the hypotenuse. And the tangent of theta is the opposite over the adjacent. Okay, so those are our basic formulas that we've learned about trig so far. And we're going to use them to help solve triangles now. In this picture, we have both an x and a y to solve. And we know that we have an angle that's 26 degrees right here. The question is, which functions do I use? Now, we can be very strategic about this, or we can kind of use what I call the shotgun approaches, where we hit everything and see what works. But as usual, since this is my angle, that's my perspective, we identify my parts. This is the hypotenuse, this is the opposite, and this is the adjacent. And I'm just kind of going to do the shotgun approach, where we just set up all three of these equations, and then we solve the ones that work. So, with theta being there, I'm going to start by using sine. Sine of 26 equals the length of the opposite, which is x, over the length of the hypotenuse, which is 14. That equation only has one variable. I can solve that equation to find x. So already I found a way to solve x. Now we go to cosine. Cosine of 26 is the adjacent over the hypotenuse. The adjacent is y, the hypotenuse is still 14. Aha! This equation only has one variable. I could solve that to find y. I don't need tangent. If I did the tangent equation, that's opposite over adjacent, which is x over y, which has two variables. That's an equation I can't work with right now. I don't want an equation with two variables. So I'm going to use these two equations to find my unknown sides. And once again, I can do it in my calculator, or I can get the decimal approximations for the sine and cosine ahead of time. It really doesn't matter. But let's go ahead and start doing the little more advanced way and saying, okay, I'm just going to multiply both sides by 14. Now notice, again, when I multiply by 14, I'm not multiplying the 26 by 14. Sine 26 we know is a decimal value. I'm just not going to pre-solve that and write it out. I don't need to. The calculator knows it. If you want to pre-solve it and write it out because it's easier for you, that's not a problem. But remember, if you do that, you have to go to 4 decimal places. Okay? But what we'll normally just do is we'll just go 14 times sine of 26. And it's going to give me that side is about 6.14. Same thing here. Multiply both sides by 14. 14's cancel over here. I get 14 times cosine of 26 equals y. So 14 cosine of 26. And I get that's 12.58. Now the magic test. Do my numbers make sense? I got that this side is 6.14 and this side is 12.58. Is the shortest side across from the smallest angle? And the answer is yes. 26 is my smallest angle. This is my shortest side. That is correct. 12.58 is much larger than 6.14, and this angle up here in the corner is also much larger. In fact, that's 64 degrees. We know because 26 plus 64 plus 90 is 180. So it makes sense that the 12.58 is much larger, but it's not bigger than the hypotenuse, which has to be the biggest side. So everything makes perfect sense. It looks like we're in good shape. And that's how we set these up. We use our SOHCAHTOA. Let's try again. We're going to find the value of u using sine and cosine. Round your answers to the nearest tenth. All right, so again, here's my angle, so there's my perspective. 8 is the hypotenuse, T is the opposite, and U is the adjacent. So again, we start out by identifying our parts according to the perspective of the angle that we're using. Now, it just wants us to find U, so U is the adjacent, and the known side, 8 here, is the hypotenuse. Here's my SOHCAHTOA. Which one of the functions, sine, cosine, or tangent, uses adjacent and hypotenuse? Well, sine is opposite hypotenuse. No. Cosine, adjacent. Aha. Cosine is the one that uses adjacent hypotenuse. So we're going to use the cosine function here to find U. So the cosine of the angle equals the adjacent, U, over the hypotenuse, 8. Once the equation's set up, solving is fairly straightforward. This time we just multiply both sides by 8. And in my calculator, I do 8 cosine 65. And I get that's 3.4 to the nearest 10. Now, your job is to find T. And again, round to the nearest 10th, please. Choose the correct answer. Application problems of this, again, notice we're doing angles of elevation and depression. We talked about angles of elevation a couple days ago. Today we get an angle of depression. Okay? Again, angles of elevation and depression always have to be taken from the horizontal. Since this is the horizontal, my angle has to be taken from that. I never take it from the vertical here. That would be a no-no. Don't do that. There we go. But the picture's already drawn for us, and what it is asking us is if this is a 21-degree angle, so the picture's all drawn up for us. We've got our nice right triangle. We know the drop here is 1,200 feet. We know my angle is right here. I've already got a person drawn in, so we're great. That's my perspective. Which is the hypotenuse? X 1,200. X is the hypotenuse. Which side is the 1,200? Well, 1,200 would be opposite of the angle that we're using. The adjacent side here, we really don't know anything about. In fact, it's not even going to figure into this problem. So in order to solve this problem, I'm going to have to use the sides of the opposite and the hypotenuse, because the opposite is known and the hypotenuse is what we're finding. Opposite hypotenuse is which function? So again, we look at our cheat here, SOHCAHTOA, and opposite hypotenuse is right here. Opposite hypotenuse is sine. So I'm going to use the sine function of my angle equals the length of the opposite over the length of the hypotenuse. We've seen this before where the x is in the denominator of my ratio. And if you recall, what we have to do technically is have to multiply both sides by x and divide by sine 21. But the result of it is essentially swapping these two values. So we can kind of shortcut the whole multiplying and dividing thing and just go ahead and do the swap and rewrite x equals 1,200 divided by the sine of 21. Now, we learned a while ago, it's not 1,200 divided by 21. Sine 21 is a decimal value by itself. So I can't add, subtract, or multiply, or divide this 21. It's just sine 21. So 1,200 divided by the sine of 21 in my calculator gives me 3,348 feet, 49 feet. To the nearest foot would be 3,349. It was actually 3348.5, 5 rounds up. So that would be the distance down the slope to the nearest foot. So once again, we use our sine, cosine, tangent, our SOHCAHTOA to set up an equation, and then we solve that equation. Exact same problem, but now my angle of depression is 28 degrees. So I'm going to draw the picture for you, help you get it set up. Okay, now my angle of depression is 28 degrees. It's still a 1,200 foot drop on the slope. How long is the slope itself? This time you set up the equation and solve it, and then we'll see you in class.